A lot has changed in the US over the past year, but one question blazes through it all. How is the country burned? This is an interactive visualization by Amy Zhao, Brian Cruz, and Vanessa Lau. Going through our visualization, we begin with a narrative that explains the patterns we found in our data. From California to the greater West Coast, we can see numerous very bright fires, fueled by aspects such as the region's drier summers, the Santa Ana winds, etc. Moving on to the East Coast, this region tends to be much more humid and also has far fewer fires. Contrasting this, however, looking at the southeast of the United States, despite also being very humid, it has the highest density of fires we found in our data, although the fires tend to not be very bright. Being California natives, our group's motivation for our project was to analyze fire patterns in the United States, especially in the wake of climate change. Regarding what our visualization allows that others may not necessarily is the fact that by specifically plotting the exact locations of where fires occurred, we were able to highlight these natural disaster patterns in a finer grain of detail than if we had simply done an aggregated choropleth map based on their total fire counts. Additionally, a choropleth map would have blurred the difference between a state with fewer, brighter, and likely bigger fires, see the entire western half of the US, and another state with many less bright and likely smaller fires, see the southeast. While our visualization is primarily aimed towards Americans, it's still understandable by others who are not familiar with US geography because of our usage of zooms and climate descriptions in the narration. Regarding the interactions we provide in our map, we have three primary filters. Seasons, so we could see which seasons the fire occurred in. Minimum brightness, to see the minimum brightness in Kelvin of the fires we're specifically looking at, as well as states. The dynamic line graph of average brightness per month updates in accordance with all of these. Additionally, we could press reset selection in the bottom left to reset our selection of states. We can also collapse and expand our dynamic line graph to allow for ease of viewing. Our subtitle updates in accordance with our filters. We also have a tooltip that shows the brightness, state, and specific coordinate of the fire that the user is hovering over. Despite the common narrative that California and the West Coast are the most fire-prone regions in the country, our visualization complicates that story. Because we chose not to use a choropleth map, we can clearly see that the southeast experiences far denser clusters of fire events, while the west shows fewer but often brighter burn. Our map doesn't label which fires are prescribed or uncontrolled, but these contrasts in density and brightness hint at very different fire dreams across the country. Historically, many western states restricted cultural and prescribed burning for over a century, while in the southeast, these practices continued as a routine land management tool. Understanding this broader context helps make sense of the patterns we see on the map, and that leads to our biggest takeaway. Fire isn't only a destructive force, it can also be part of a healthy landscape. By understanding where and how fires burn, we can start shifting the narrative from fear towards informed management. Fire isn't the enemy, mismanaged fire is.